Eighth grade math ninjas. Quotient of powers, right? Weird words, but no, not quotient, division, powers, exponent, quotient of powers. We're going to pause this here, getting going. I want you to stop. You got 2 to the power of 4, 2 squared. It's number 1. Number 2, negative 4 in parentheses to the power of 5, negative 4 parentheses squared. I want you to expand that. I want you to write it out and just sort of work with it, play with it for a second. Okay, so pausing, journals out, writing in expanded form, so without exponents. Do it. Okay, so maybe you came up with something like 2 times 2 times 2 times 2 over 2 times 2, right? And so what we're seeing here, in this case with exponents, as you guys know, 2 divided by 2 is 1. 2 divided by 2 is 1. And so what you're left with is what? 2 times 2, or 2 squared over 1. So you're left with 2 squared, and of course you could call that 4. All right, but we're sort of playing with exponents, so we're thinking about it still with exponents, 2 squared. And then here, you probably had negative 4 times a negative 4 times a negative 4 times a negative 4. 1, 2, 3, 4, 5 times a negative 4. Okay, divided by, it's a 4. Negative 4 squared. So a negative 4 times a negative 4. Right? And same thing here. You're thinking a negative 4 divided by a negative 4 is 1. Negative 4 divided by a negative 4 is 1. What am I left with? A negative 4 times itself 3 times. So make sure you keep those parentheses. Last week we emphasized how important it is that if there are parentheses, you honor them. You keep them there, okay? And so we could figure that out as well. A negative 4 times a negative 4 would be positive 16. Positive 16 times a negative 4 would be a negative 64. Tell me if I'm wrong. Okay. So continuing on, quotient of powers. Let's look at what the general idea is here. So the general idea is, again, expanding it 3 times 3 times 3 times 3 times 3, divided by 3 times 3 times 3, 1, 1, 1 is equal to 9, or 3 squared. So it's equal to 3 squared, or 9. Okay. And then let's look at this one, and I'm going to generalize with this one. So here you're seeing x times x times x times x times x times 1, 2, 3, 4, 5, 6 divided by, right? And I'm just going to do this 1, 1, 1, 1, 1. You're left with x. So maybe even already right now, some math ninjas are seeing a pattern. And the general rule here could say if you have any variable, actually, let's use, sure, let's use y. So if you have any variable, we're saying y, to the power of anything, let's say m, and any variable y to the power of n, the general rule is you could say it's y to the power of m minus n, right? That's a general rule, the general idea, right? The important thing is that you could see 3 to the power 5, boom. 3 to the power cube to the power 3, boom. I can see that there are ones. I see that that's 3 squared. I see that that's 9, right? That's cool. And then it's algebraic thinking to start to generalize patterns. So you're like, okay, cool. If the bases are the same, by the way, right? The bases are the same. Make sure that's true. To a power of m to a power of n, it's always going to be m minus n. We see that here. M to the power of 5, 5 subtract this, the cube, to the power of 3 would be 3 squared. X to the power of 6 divided by x to the power of 5, well, 6 minus 5 is x to the 1, which we don't bother writing. It's just 1. If we go back here, you would see 4 minus 2 is 2 squared. 5 minus 2 is cubed, negative 4 cubed, right? So you can start to generalize this pattern. And one more problem I wanted to do for you guys right here. So mathematics is about being creative and flexible with your thinking. So here you should be thinking, oh, okay, this numerator we did last week. This is 6 times 6 times 6 times 6 times 6. That's 6 to the power of 5, right? If you expanded it, you would see that's 6 to the power of 5. And then here on the bottom, 6 to the power of 4. And again, like you could expand that numerator, right? 6 times 6 times 6 times 6 times 6. 6 cubed, 6 squared, so 6 to the power of 5. And then, as if we use this general rule, we're thinking, okay, 4 of those are going to become 1s, right? 6 divided by 6, 6 divided by 6, et cetera, et cetera. So it's really 5 minus 4. So 6 to the power of 1. And we usually won't bother writing that power of 1. So you can check this. I use the general rule. You can check it if you're not convinced. Here are your practice problems. So you are going to, in the video stop, copy down these practice problems. So in parentheses, negative 5 to the power of 5, in parentheses, negative 5 squared. That's problem A. Problem B, y to the power of 19, y to the power of 17. And there you're saying like, okay, I want to use that general rule because I don't want to write 19 y's. Here you could write it expanded, right? That would be, they're small enough. C is note you have some work to do in the denominator first. 9 cubed times 9 cubed, all underneath y to 9 to the power of 7. And then here is pi. Pi is a math symbol. It has a mathematic value. It's an irrational number. It's 3.14159 something, 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 something. Right? So you've got pi to the power of 30 divided by pi to the power of 18 times pi to the power of 4. You've got four practice problems. Do them well, add them to your notes. Be a ninja.